everyone! Welcome to the Wings Engine Secondary Development Tutorial. In the last class, we have introduced the entrance of secondary development. In this class, let's take a look at the simplest concept in secondary development, which is the most basic concept, the life cycle of extensions. First, let's go to our documentation to see what extension is. Normally, we should go to the development overview. We expand this component and find the basic tutorials in secondary development and click on the extension Lifecycle. Let's take a look. For our basic secondary development class, for example, we wrote a class named Button. It implies an inheritance, which inherits the extension class. That is to say, here is a class that extends extensions, class. This class has a life cycle, the entire life cycle of our components. The creation, running, and destruction of the code. Running and destroying is executed by calling these life cycles. Then you can in the life cycle to write your own code. In this way, indifferent, such as when initializing, to initialize some specific variables, to change its position during updates, and when destroying, to clean up some variables, such as arrays, such as variables that take up more memory, to prevent the GC from being too slow. Therefore, the life cycle of extensions is also a very important concept for us. Let's briefly introduce it to you now. There are 4 methods in total, which are init, ready, updated, and destroyed. Among them, I will first talk about init and ready. Both init and ready are used for initialization code. For example, I said, I want, initializing the position of the very beginning. Or some initial variables can be placed in init or ready. What's the difference between these two lifecycle methods? What's the difference? We can see this comment here. The biggest difference between them is that init only focuses on itself. That is to say, for example, I initialize some variables within this that itself, initialization, then write it in init. While ready, it needs to pay attention to other components. It actually waits for all the components in the scene have been called. After init, it will start to call the ready of each component. That is to say, for example, when this button, this component depends on a button too, and another component especially relies on the init method in button 2 is executed to initialize my button 1 component. So, then my logic should be written in the ready method because ready will wait for the in method of button 2 to finish before it executes. This is the ready method. And destroy. Destroy is for the entire. Clean up the entire extension. Normally, there are the following situations. The destroy method will be automatically called. First, when I close this code file, That is, when we unmount the entire script. It would call the destroy method. Secondly, when we close the entire project. Thirdly, if our project is in an external environment, when we open and close the entire page, the destroy method will be called. The destroy method. It focuses on cleaning up or ready to initialize large arrays or maps, and so on. Variables that take up more memory. I'll clean them up here. For example, I call clear, right? Or set length to 0. If length is 0, in this way, we don't have to wait for the garbage collector to clean up these variables. This optimization of memory is very beneficial. Finally, there is the update method. The update method. As you can see, it needs to be called every frame. What is every frame? We know that in Cesium, there is a method called request. Animation frame. That is to say, every time the entire screen refreshes, it will be called once. This is especially suitable for writing animations, such as position updates. However, it is not suitable for writing some computations that consume a lot of performance. This is something we should pay special attention to in our real projects. We often see some code being opened. It may need to calculate every frame. But there are some pre-calculation methods, which should be written in any to or rendered. They don't calculate. It calculates at every frame. This will consume a lot of performance, especially when we see the lower right corner. The FPS will drop significantly. Okay, this is our entire life cycle. Today, let's write a small example together. I want to use the Lifecycle method. It doesn't calculate the update method to let our object move this component, moving in the screen. That is, changing its X value. Let's see how to do it. First, we press the Edit button and open this class. The simplest way is to directly write it in the update. We wrote one here. Our idea is to set X++. That's probably the idea. How do we implement it? Okay, we've actually talked about this before. We click it and find it to take a look. This is its component positioning. For example, here, I actually know that we can use the scroll wheel here. We can see that. We just need to control this variable to control its X. We click here and find its calling code example. Let's copy it. Okay, let's paste it here. We need to connect this X and Y. Note that for something like this, 1 by 1, or 1 by 2, 3, or 1, 2, 3, we can use arrays to receive them. In this way, we can use the variable position to this variable. Then we just need to put it back in the same place. Component position is here. Call the code example. Let's copy it. Okay, let's paste it back. Paste it back here. We just need to add one to X. Okay, that's it. We saved it with CTRLS. Then go to this code. And then refresh it. You can see it, so it can automatically turn right. Of course, for the following code, can we optimize it further? It's also possible, especially what I said earlier. We should minimize the logic in the update function. In the update function, not only did we add, but also to get it. This option, actually. You can further optimize it. Put this thing in the ready. And only perform additions here. In this way, we can further optimize the entire code. Optimize it. Okay, that's all for today's class. Thank you all.